Atoms in a covalently bonded molecule continually compete for shared electrons. Electronegativity is a concept that describes the tendency of an atom to attract a shared pair of electrons towards itself. Some atoms have a stronger pull or attraction for shared electrons. These atoms have a higher electronegativity. Some atoms, on the other hand, have a smaller or weaker pull for electrons. These atoms have a lower electronegativity. Let's take a look at this periodic table. If we look at fluorine, we'll see a number under it. And since this is a special periodic table that has electronegativity values, we'll see that 4.0 is fluorine's electronegativity value. Oxygen next to it is 3.5. So let's compare these real quick. Fluorine has a bigger number, 4 compared to 3.5, but what that means is fluorine has a higher electronegativity, which means fluorine will attract electrons stronger than oxygen. So if you compare any two atoms on this periodic table, you'll be able to see if they pull electrons stronger than the other or the same. Some elements will pull the same amount, and then some, if we take a look at cesium, which is 0.7, and then maybe nitrogen up here, there's a big difference between these two. 0.7, it's a very low number. It's not going to pull electrons much, but nitrogen, when compared with that 0.7, it is going to pull those electrons very strongly away from the cesium. In molecules of only one element, the pull toward each atom is equal because each atom has the same electronegativity. So, for example, we're going to draw H2. So to draw it, we need to know how many valence electrons it has. And hydrogen's the first element, so it only has one electron. So it would look like this. And since there's two of them, we're going to draw another hydrogen next to it. But I'm going to put the electron on the left side because we know that they're going to bond together. Now that we have the Lewis structure for this hydrogen, let's write down the electronegativity numbers. So if we go back, we'll see hydrogen is 2.1. Oh, and you'll always be given this kind of periodic table for a problem, so you don't have to memorize these numbers. Okay, so hydrogen's 2.1. Hydrogen's also 2.1. And what we have here is when we subtract, because it says subtract next, we're going to get 0. If you could imagine this, let's say that you were standing on this side. All right, so here's your little stick figure, you. And we're doing a tug of war. Okay, so you're pulling in this direction. I'm not sure why the rope looks like this, but, you know, just to make it look different than your arms. Okay, and then let's say that on this side, it's also you. Because if you take a look, they're the same, right? So if you're on one side pulling as hard as you can in this direction to the left, and you're on the other side pulling as hard as you can on the right, will you ever win? No, it'll be a tie, right? So you're pulling the same amount of force on both sides. So because there's no overall winning here, or you're not overall moving to one direction, either the left or the right, we would say that this is a nonpolar covalent bond. Because that number, when you subtract, we got 0 here, but if it's anywhere between 0 and 0.3, we would say the same thing. We would still call it nonpolar covalent bonds. Now in the future problems, I'll show you what happens when these numbers aren't equal. But for right now, if you have anything bonded to itself, even fluorine, which was really electronegative, remember that was 4.0? It's still 4 and 4, so when you subtract them, you'll still get 0. So it's just kind of like in this situation, if it was like me pulling against myself in this tug of war, it would be two smaller things. But then if we have these two huge, maybe football players, but it's still the same person, when they pull, even though they're stronger, they're still not going to be able to make any movement. It's going to be the same. So whenever you have this where it cancels itself out, it's called nonpolar covalent.